Okay, so two things we want to achieve today briefly and quickly. The first one is not something special, in the sense that it won't take us much time. Disproof by counter example. I believe we know the meaning of the word disproof, which means you want to say that thing is, whoa, what you're saying is wrong. Proving is trying to establish that it's a fact, right? Disproof is the other way around. Yes? That, oh, your assumption is wrong, okay, because of this reason. And you don't have to give too many reasons. You just need to state one reason, one example. And usually those examples are not in abstract form. Unlike when you are proving, you don't prove by saying, if I ask you to prove, for example, prove that maybe a plus b all squared equals a squared plus 2ab plus b squared. I'm just, of course, nobody will ask you to prove this. Prove that this happens. You are not going to say, oh, let a be 2 and b be 3. Then you substitute, you get 5 squared, then you try to substitute here. This is not how to prove. Did you get my point? Oh, 2 plus 3, then you square, you say this is 25, then you go to the right hand side, 2 squared, 2 times 3, then 3 squared, 4, this is 12, this is 9, and you say, oh, this is 25, end of proof. This is not a proof. It works for 2 and 3. Maybe it fails for 1,010,000 and B as 10,020,000, maybe. But if you are able to establish this with A and B, X and Y, M and N, and stating that A and B are any number, and you're able to establish the fact, then it works for all numbers. That's a proof, okay? But in the case of disproof, you just need to look for concrete examples like this to show that, fine, you have made a conjecture that, oh, this works for all numbers. But I can find one example. There is a point where it fails. Then I've disproved it. That's what we mean by disprove by counter example. Counter example. You know what counter means? Counter attack. The reverse of something, right? Okay. So that's why I said we only need to show a concrete example when the conjecture fails to hold, and that is the end of the work. So this is not like the lengthy proof that we normally do. Okay? So one question that I want us to just do quickly is, there is this statement that, bring your calculator now. Okay, well, before the calculator, let's just go straight to the Excel spreadsheet. Go to Excel spreadsheet, either online or offline spreadsheets, quickly. So on one column, I need you to put N. On the other column, I need you to put N squared. Well, you can't type in N squared, but maybe N, find a way to put it in your column. Let me erase this. Venom, am I here? Okay. On one column, N. On the other column, N squared minus 2N plus 41. Well, you won't be able to type that in as the heading, so you can just type something like this. Okay? Just to show what that column means. N squared minus N, actually, not minus 2N. Minus N. I'm asking you to use Excel so that we don't have to repeat the same thing. So here, I need you to put 1, 2, 3, 4. So when you type in 1, 2, 3, 4, highlight it. When you highlight, there is something here like a plus sign. Okay? Then drag it down and stop at 10. 1, 2, 3, 4. Writing 1, 2, 3, 4 is to tell the computer the pattern you want it to generate. Okay? When you drag it down, you are telling the computer to proceed the same way. Have you gotten up to 10? Good. So on the other column, I hope we know how to do N squared. Just say N times N. So just put yourself, so you put equals to, does everybody know Excel function? Okay, maybe not. Equals to, then you put your cursor here. So let's say this is A3, for example. Okay? So it's going to say equals to, you're going to see A3 here the moment you put your cursor here. Did you see that? Yes. Then times, type in A3 again. So that is the square of this. Does that make sense? Minus A3 again, which means minus n. Does that make sense? Then plus 41. Then enter. Did it work? So now, highlight that and drag it down up to the 10th row. Highlight this result. You're going to get 41. Highlight that and drag it. Did it generate others?
Yes. Oh, I like that.
She's such a baby, that's why. So I liked that 41 and drag it down. Now, what numbers did you see? 41 followed by what?
43.
Followed by?
47.
Followed by?
53.
What are those numbers? They are prime numbers, right? They are prime numbers. So, can we extend this 1 to 10, okay? Extend this 1 to 10 because we want to make a conjecture that this is a prime. Okay, it's always going to be a prime. Extend it up to 20 now. Highlight this and extend it up to 20. Then highlight what you have done here so far and also extend it up to 20. No, it's going to say 10, 10 unless you highlight everything. Or highlight the first three especially, yes. Yeah, good. Up to 20. Just highlight 3 here. Once you, yeah, then, yeah, that's it. Have you extended it?
Yes.
What do you notice about those numbers? So I ask you to open Google so that if you are not sure if 421 is a prime number, you can put it on Google. Is 421 a prime? Then you will see if it is a prime or not. All right? So check. Is 421 a prime?
Yes.
It is?
Yes.
Okay. What about the previous number? 383. Check. Is it a prime?
Yes.
So check any number you are not certain of. 251, for example. Is it a prime?
Yes.
So with this, somebody might just make the assumption, I haven't run this Excel function for the first 20 numbers. And say, so the assumption will be, okay, here, the assumption will be for all n in n, right? Let's see. N squared minus n plus 41 is a prime for all natural numbers n. Just by doing 20, conclusion has been made. This is a conjecture. It's not proved yet. We have only done a few experiments. All right? And from our few experiments, we have concluded. But that doesn't make it right. Okay? So the question here is to disprove this using a counterexample. So all we have to do now is now investigate at what point does this statement fail to hold. Do you understand? Can I ask you to do that in 5 minutes? You can use your Excel function and just try to find a point whereby the number generated is not a prime. Can you try? 5 minutes. You can always use your Google to verify if that number is a prime or not. Two 2021 is not a prime? Is that what you're saying?
Yeah.
What's the value of n that gives that? 35. 45. Did you hear that? It fails at 2021. Did it fail before then or after then? You can give us different values. But you only need one anyway. You don't need like 2 examples, 3 examples. When you're trying to do counter, remember, opposite of for all is to find only one where it doesn't happen. Okay? You are proving for all, right? The moment one is wrong, then that for all doesn't hold anymore. Do you get that? That is why we only need one example to disprove something by counterexample. She has found when n is 35, you will get a number 20221, am I right? 2021, which is not a prime number. So that statement is wrong, particularly for all. If the statement was, this is a prime for some n, then the statement is right. But it says for all, that's what makes it wrong. Okay? Brandy, I thought you were going to check for 41. Is it a prime?
It's a prime.
It's a prime. Oh, okay. So there are different values where you can actually see. So this is how to disprove by counterexample. So when I've typeset some problems, I was going to protect them, but of course, unfortunately, due to this change of class thing, I'll put it online again. I hope everybody can access the folder. Krista, can you access the folder now? Can you? Okay. So if I update it, all you have to do is, like I said, download the updated version and delete the previous one. Because once I maybe solve the net and I see some related question, I like to put it in the question bank that I've typed. Okay. So that's. Yes. You found one?
41 is actually not.
41 is not a prime. Did anybody notice that also?
I think it's.
When n is 41, you get a number which is not a prime.
41 times 41.
41.
What do you mean 41 times 41, Leo? We're talking about the expression, not 41 squared.
1681, right?
It's not. It's 41 and.
Even at 1? No. Even at 1 is 41. 41 is a prime.
No.
No, the result you get when n equals 41 is the square of 41. That's what
41 times
like
41.
you add
Oh,
when n
I
is
see. Because when n is 41, it's obvious. Minus 41 plus 41 is 0. Then the result is just n squared. And that is not a prime. So it makes sense. Okay? Questions? Alright.
Can we just write this is not true?
Yeah, so to solve this, for example, say you just have to say when n is 41, n squared minus n plus 41 equals 41 squared minus 41 plus 41, which is just, I can even write it as 41 squared, I don't need a calculator. Alright? And just conclude which is not a prime. Because a prime is meant to have only 2 factors, right? This is having 4 factors. No, 3. 1, 41, and the square of 41. Okay? So that's not a prime, which is not a prime. So that statement is wrong. That's all you have to write. Okay? Just give one example where it fails, explain why it fails. That's the reason I said which is not a prime. Because the statement says it must be a prime when you evaluate it. Okay? You could do the 25, somebody discovered 25 also, right? Is it 35 or 25? No, 45. Yeah, you can check at 45 also. Okay? Alright, so that's all about proving by counterexample. So quickly go to the other one because of our time. We have just 18 minutes left. I put some questions on the online. I'll put it online. I don't think I've uploaded the question yet. Please do as much practice as possible. So to discuss proving by counterexample, I'll put this as the general thing we need to talk about. Converse, inverse, and contrapositive. For any statement, let's see the converse, the inverse, and the contrapositive. Then it will make sense to us when we're discussing the proof. For the statement, if P, then Q. Okay, this is a statement. It's a conditional statement. We talked about this when dealing with conditional statements. And if P, then Q can actually be written as, how do we write it? In symbolic form. If P, then Q. Form of a symbol without using words. P, speak louder, implies Q. The arrow, yes, that's implied. She said arrow. So this is if P, then Q. P implies Q. Okay? The converse, let's write. The converse of this statement is what? Anyone? You give me first in this form, then in that form. What is it? Yes?
If Q, then P.
If Q, then P. If Q, then P. And in symbolic form, class, Q implies P. What about the inverse? Can somebody try? Inverse of that statement.
If P, then not Q.
Close.
If not P, then Q.
If close.
If not,
If not P,
If not P, then
If not P, then not Q. It makes sense. If you say, look at this. Let's have an example here. I hope this doesn't cut my leg off when it falls. Give me a conditional statement. If you have a job, then you earn money. Of course, it doesn't mean that having a job is the only way you can earn money, right? But of course, if you have a job, then you earn money. Then you earn money. Or let's say then you earn salary. That is the only way you can earn salary. Not the one you get from your parents. Whereby the only job you do for them is what? Eat their food.
Or freelancers.
All right. If you have a job, then you earn salary. That is the conditional statement. The converse will be what?
If you earn salary.
If you earn salary, then you have a job. Okay? The inverse will be what happens if you negate both of them. What's that?
If you don't
If you do not have a job, then you do not earn salary. Now, the contrapositive is the converse of the inverse.
If you
don't have a salary, then you don't have a
That is it. That's why I put them all together.
It's like,
Okay? So inverse will be, yes, if not P, then, yes,
then
not Q. How do we write that in form of a symbol? P inverse, okay, implies, talk to me, negation. So negation, we call this negation. In your textbook it's written this way. I think this is the symbol used. But that's kind of strange to me. That's why I use what I'm used to.
7P.
Okay, it's just like this.
Oh, so go up.
Yeah, just combine your two eyebrows together.
You need
No, actually, no. Like the left eyebrow, then the right eyebrow is minus 1, combined together.
just go with
Because the two eyebrows looks like this, right? So just raise this to power minus 1, Karen. Then combine them together. Okay? Okay, so now C, contrapositive. So again, what is a contrapositive, everybody? If not Q, then not P. Not then P, then not P. So to be negation Q implies what? Negation P. So basically, contrapositive is this is, just for a reminder, this is the converse of inverse. So now open your textbook quickly to page 227. Come on, we have like 12 minutes. Page 227. Are you there yet?
Yes.
Exercise 9G. Are you there yet?
Yes.
Exercise 9G, page 227. So let's state the contrapositive of those statements. The first statement says, if it is raining, then you will get wet. What is the contrapositive?
If you don't get wet,
If you do not get wet,
it's not raining.
then it is not raining. Good. if penguin can fly, then it is Thursday.
If it's not Tuesday, penguins can fly.
If you drink alcohol, then you must be age 18 or over.
If
You're
you're
not age 18.
If you're not age 18 or over, then you don't drink
Then
alcohol.
you do not drink alcohol. Just negate the statement. Don't try to make it, what is the problem? Are you drinking alcohol? You seem to be interested in that. Something. What? What?
What?
Alright. If k is divisible by 5, then k is not a prime.
If K is prime, then K is not divisible.
Good. And finally, if a squared plus b squared equals c squared, then a or b is even.
If A or B is not even,
A squared plus B squared is not equal to C.
That's it. Or you can say if a or b is odd, because that's opposite. As long as it's opposite, you don't have to use the word not. You can always use a negation, as long as you negate the statement. Okay? For example, it says you must be age 18 or over. You don't have to say not. You can just say you must be below 18. That is the opposite of that statement. Does that make sense now?
Yes.
So, some proofs can be done easily by contrapositive. And because if the first statement holds, these are equivalent statements. Okay? I'm going to write that. All the statements, the converse, the inverse, the contrapositive, they are all equivalent. Because this will only happen if you have a job, then you earn salary. It's equivalent to if you do not have a job, then you do not earn salary. Are they not equivalent? Do you get my point? It's also equivalent to you earn salary. If you earn salary, then you have a job. Do you understand that? Which is also equivalent to if you do not earn salary, then you do not have a job. All these four statements are equivalent. They are passing the same message. Am I right? So because they are equivalent, you can prove one of them to represent the others. Does that make sense? So if you have a proof, I'll give you an example. One of the proofs here says, prove by constructing a contrapositive. If n squared is even, then n is even. Let's look at that. If n squared is even, then n is even. Now, it's difficult to construct something with this. This is the given. This is what you must establish. If n squared is even, so I say, oh, n squared must be in the form of 2k. I must be able to show that my n is in form of, say, 2m, right? It's difficult to do that here. Because even if I take square roots, I'm going to get the square root of 2k, isn't it? How do you simplify things like that? To be able to get 2 out. Can you see how you can get stuck in proof sometimes? But if you construct the contrapositive of this statement, what would be the contrapositive of this statement? If n is odd. You don't have to use the word not. Okay? If n is odd, then what?
N squared is odd.
Isn't this easier to prove? If n is odd, then n is in the form of what? 2k plus 1, right? Then you have to be able to show that n squared will also be in this form. Is that easy to do or not? Do you understand that? So if this happens, then you expand n squared and you are able to get 2n plus 1 form of the number. And because you have proved the contrapositive, you have proved the original statement, because the two statements are equivalent. Does that make sense? So this is how to prove by contrapositive. So the same idea of direct proof. So you can see that we are actually invoking direct proof. We only need to change the statement to prove directly. Do you understand? You can still use direct proof and the proof by exhaustion under contrapositive. The whole idea of contrapositive is you rephrase the statement to make it the same, the original equivalent statement, and prove any way you want. Okay? You can change the statement to contrapositive, and maybe you can disprove it by counterexample. If it doesn't make sense to you, that, oh, this is the equivalent of the statement, and this is wrong because it fails at this point. Am I making sense now? So we have about 5 minutes. So I'm going to take 2 problems. So let me write something here first. Let's write quickly. The first statement, that is original statements. What do I mean by the first statement? The original statement. What's the next one? It's converse. Good. It's inverse. And it's contrapositive. Are equivalent. Okay? By this, proving any of the 4 proves all the 4. Because they proves any of the 4 actually is a proof to all of them. So that is the whole idea of proving by contrapositive. If you try to use direct proof and it doesn't work, you think, oh, can I construct a contrapositive? Mind you, this is usually applicable in the cases where you have a conditional statement. If this happens, then this happens. Okay? So before we go in about 2-3 minutes, I just write the example we are trying to discuss. Prove that if n squared is even, then n is even. Okay? Prove that if n squared is even, then n is even. Bernard, are we here?
Isn't this the one that we did just now?
No, that's the statement. It's one of the exercises. If you look at that 9G, that's 2A.
That's the example just for me.
Yeah, I just want to draw it formally now. Okay? So the proof is as follows. So I'm going to put a remark because it is difficult, just for you to remember why. To prove directly, we will prove the contrapositive. Okay? So this is how you will begin. Say, the problem is equivalent to if n is odd, then n squared is odd. Okay? Yes.
So in these questions, like, do you choose which one you use?
Yes. If you are not, it is not specified. In the worksheet, I will specify you must use contrapositive. But in the general exam, IB or university, you choose which one works. One might not. Look at this, for example. Direct proof fails unless there's a way somebody can think about it. Okay? But if you look at, oh, contrapositive can work, then you use contrapositive quickly because you have 2 minutes to your next lesson. So equivalent to this. At the university level, what we always write is, it is enough. Okay? To show the problem, you don't have to use this writing.